This is the first of several videos on graphing polynomial functions of higher degree. Just about anything can be graphed using a t-chart. It's not the best method, but I am showing you this just so that you get to see what this type of function looks like. Using a t-chart is a hassle because of the arithmetic. If you make a couple arithmetic mistakes, your picture looks wrong. -3, -42 really is further down the graph. I just couldn't fit it in. It's just way down here somewhere. Now, if I want to connect these dots, this is going to be a matter of starting here, coming up through here, reach a peak there, come through there, come down, come back up. And rather than me trying to draw it by hand, here it is already drawn for you. That's just to show you what one of these functions looks like. But this is not the best way to graph it. There are a couple little tools you're going to have to put in your tool belt to be able to put graphing the function together where you don't have to use a huge t-chart. So let's look at something called left-hand, right-hand behavior. When you're graphing a polynomial function, it's helpful if you understand the left-hand, right-hand behavior. That left-hand, right-hand behavior depends on two things. It depends on the lead coefficient of the term with the highest power. Now notice all of these functions I have written in descending order of exponents, and that's how most of those are written. If you come across one that's not in descending order, you want to write it in descending order so that you are looking at the correct first term. It's not necessarily what you see first. It's got to be the highest power and its coefficient. What do you notice about all of these functions? Hopefully you see that all of these fall down to the left. They continue forever and ever down to the left. They also will rise to the right. Now they may do some other stuff in between, and I'm not concerned about that. They wiggle a little, they wiggle a lot. What happens for sure is that on the left here, they fall left, and on the right, they rise right. What do you notice about the equations? This is 2x cubed, 3x to the fifth. Notice the power. Those powers are all odd. Notice the coefficients. They are all positive. When you have the combination of odd lead power with positive lead coefficient, you're going to have this situation. So this looks fancy. Let me explain what all of this writing is. This is called the leading coefficient test, and this is for any polynomial in this form, which is really what I had on the other page, or is this right here. If you look at this compared to this, the a sub n is your coefficient, so that's like 2. The x to the n is your variable with a power, x to the third. Then we go to the next coefficient and the next power and so on. Notice it is in descending order. So what we just looked at on the other page is the idea that if you have this power being odd and this coefficient being positive, it will fall left and rise right. So this right here is an example of that. And on this screen right here, I've got it graphed for you. Same function as the other page. And I've graphed it using a graphing utility. But notice it is falling left and it is rising to the right. We will learn later on to find out where it crosses the axis and how to figure out how high it goes and how low it goes, but that's later on. All right, another set of possibilities. Take a look at your powers. All of these powers are odd, but the coefficients now are negative. Notice what happened. We're in the opposite direction. We are rising left. Every one of these is rising to the left, and it is falling to the right, falling down to the right. That's the second possibility. And that if you have an odd power and you have a negative coefficient, of course with this one just a negative, there's like a -1. If you have an odd power and a negative coefficient, it's going to rise left and fall right. So let's graph this -x cubed plus 4x. There it is. It is rising left. It is falling right. So that was odd power, negative coefficient. Next thing to look at will be even power. X to the fourth, x to the fourth, x to the fourth. There's nothing fancy about using the 4. It's just what I happen to have used. I could have done x squared. I could have done x to the 6. But what is important is that on the left and the right, both of these rise. It rises left and right. Rises left and right for all of these. So this is the idea that you have an even power and you have a positive coefficient. If n is even and the coefficient is positive, that's a 1 right there. then it's going to rise, rise, rise to both sides. Let's graph this one on the next page. There it is. It's rising to the left, rising to the right. Last possibility is even power, but a negative coefficient. If that happens, notice we are falling both directions. Falling both directions. Notice also, not that it matters to the lead coefficient test, sometimes that falls and does a little wiggling, sometimes it sort of looks like a parabola. That's all stuff we'll look at in other videos. All we're looking at right now is what happens on the ends. This is either called left-hand, right-hand behavior, or some books just call it end behavior. So in words, what we just looked at there, if this n is even, the power's even, and you have a negative coefficient, it's going to fall, fall. An even power, we have a negative coefficient, it falls both to the left and to the right. So putting all of those together, we've got four possibilities. Exponent being odd with a positive coefficient, it falls left, rise right. Odd exponent, negative coefficient, it does the exact opposite. It rises left and it falls right. With the even situation, it does the same thing both times. Even positive, it rises left and rises right. Or if it's got a negative coefficient, it falls to the left and it falls to the right. So these two are both going in the same direction. Sometimes up, up, sometimes down, down. And these two are just opposites of each other. So let's see if we can figure out what's going on with these. Because of the odd power and the positive coefficient, it's going to look like this. It's going to fall to the left, it's going to rise to the right. Negative x to the fourth, blah, blah, blah. And it doesn't matter what comes after this. What matters for this test is just this lead. We have an even power, we have a negative coefficient. This one's going to fall, fall. This has an odd power with a negative coefficient. That's the exact opposite of number one up here. So this is going to rise and it's going to fall. X to the sixth, that's an even power with a positive coefficient because there's like a 1 here. That is going to rise, rise. So you can use these little arrows like this if you want, or you can actually write out fall, left, rise, right, whatever your instructor wants you to do.